Welcome back to Daniel's extra chemistry classes. In the last class, we discussed laws of chemical combination, Dalton's atomic theory, atomic and molecular masses. Today, we will discuss some very important ideas like mole concept, mole and the number of particles, molar mass of elements and compounds, mole to number of particles using Avogadro number, and mole to mass of substances by using molar mass. Okay, I have talked to many students who are a little confused by the mole concept. At first, I want to explain why the number of atoms and molecules are important in chemistry. Then I will give some ideas to make the concept easy for you. Each chemical reaction involves a specific number of atoms and molecules. For example, let's think about the reaction between hydrogen and oxygen. Okay, in that, the molecules are reacting in a 2:1 ratio. This, happens whatever, amount of water you need. Always they, react in 2:1 molecular ratio. So, how to take the number of these molecules? Okay, they are too small, too tiny. So, how will you take those, number in that particular ratio? You can count by weighing. That's a very, very important thing. But how? Let's take a typical, scenario. You have a class project in which you need a 1,100 nails to complete that project. If you go to a metal store, the storekeeper will say, I have no time to count the nails for you. But fortunately, that particular storekeeper was a wise person. He gave you the packet of nails and asked you to count 10 nails to him. So he took the 10 nails, placed on the balance, found out the mass, and then found the mass of the 1,100 by just multiplying weight of 10 nails with the 110. And he got the total mass, and he weighed out and added a few, extra to make, sure. And you are happy. So that is how we count by weight. Okay. Now, so you will be asking, what about atoms? Okay, atoms are too small. So let's take this particular thing. Hydrogen atom, see, you already know that the approximate atomic mass is 1 AMU. And we define the AMU as 1.66 10 to the power of negative 24 grams. Okay, now, suppose I want to weigh out 1 gram, at least 1 gram is needed for, a good weighing or a little correct weighing in my balance. So, I need 1 gram to weigh 1 gram. So, how many hydrogen atoms I will have in that 1 gram? I can calculate it because I know the mass of one, a hydrogen atom in grams. So, just divide the 1 gram with the 1.66 10 to the power of negative 24 gram. I'm going to get what? Going to get how many atoms of hydrogen are needed to make that 1 gram. Now, I want you to just calculate this. Just pause the video there. Just calculate this number, 1 divided by 1.66 10 to the power of negative 24. Now, if you are using an ordinary calculator, you need to place a parenthesis, for the denominator. But if you are using a calculator like mine, which can have a function, a exponent function, you can use that function also. And if you calculate it, you're going to get a number, near about 6.02 10 to the power of 23. And if you're not getting that, that means you are not doing the calculation correctly. But we are using an approximate mass for the hydrogen atom. If we use the correct atomic mass, the number is going to be 6.022 10 to the power of 23. And this number we usually call as Avogadro number. This is a very large number. Okay, how large it is? Let's take a particular scenario. Okay, you actually, it's an imaginary thing. Don't think it is a real thing, imaginary thing. You are praying to God. And God came and gave you asked you to just, give a wish. So, I mean, he wanted to give you a wish. Okay. And asked you to, what wish you want? So, this was so sudden because God appeared very suddenly. You don't know what to answer. But you remember that you studied in the class about the mole. And the teacher told you the mole is a large number. So told him that you wanted a mole of ladus, the sweet, sweet thing which you have. You like sweets, so you say, I need one mole of ladus. What happened? In the next moment, you are on the top of a very, high miles and miles, a heap of ladus, and you are lost, and you are far away from the earth. You cannot even see the earth. And this is an imaginary thing. Just wanted to tell you that the mole is so large a number, we don't use it for ordinary things which around us, which we can see or touch. So that's the idea. So that number you just remember. Okay, and let us come to the mole concept. Come back to the mole concept. A collection of 6.022 times 10 to the power of 23 atoms or molecules is said to be a mole of that substance. And that number is called the Avogadro number or Avogadro constant. Okay, so this number doesn't change. Whatever be the substance, whether it be atoms of hydrogen or molecules of oxygen or molecules of water, molecules of any substance, that number doesn't change. Just like a dozen. See, I have a dozen eggs here. I brought a dozen eggs. Okay, and I also have a dozen nails here. Both have the same number. That doesn't change. Always a dozen means you have a 12 number of items in that particular collection. Okay, but are the weights the same? No. We never can say the mass of 1 dozen eggs is the same as the mass of a dozen nails. They are different. So the number doesn't change, but the mass is different. So how about finding the mass of a mole, which we call as the molar mass? Okay, let's take that. Okay, we already have defined the carbon, and the atomic mass of carbon is 12 AMU. We know that is a relative mass with a, we know the unit. So approximately we can say this is 12 times the mass of the hydrogen atom. 12 AMU, we can calculate the absolute mass by substituting the AMU with the number which which is equivalent, which is 1.66 10 to the power negative 24. So if you multiply 12 and this number, we indicate the absolute mass in grams of a carbon atom. And mass of 1 mole of carbon atoms will be what? Whatever you get here, the previous column, that's what I just put here as previous column. Multiply whatever you got here with the Avogadro number, because the mole contains Avogadro number of atoms. So multiply that with the Avogadro number and you are going to get what? At 12.0 grams. Okay, let's repeat it with any other atom. For example, oxygen atomic mass is 16 AMU. Multiply the 16 AMU with the Avogadro, with the AMU equivalent, which is 1.66 10 to the power of negative 24. That's the mass of an oxygen atom. Okay, then if you want the mass of 1 mole of atoms of oxygen, multiply whatever you got that with the Avogadro number. And again, it happens to be 16 grams. So what is the point which I am talking about? I'm saying that your atomic mass, which is for all atoms or all elements, atomic mass is given in the periodic table. I got a periodic table here. So a very important resource you have. All atomic masses are there. So that atomic mass is in AMU is the mass of the atom. But if you take 1 mole of atoms, that is your group of atoms which makes 1 mole, it's going to be the same number, only the unit is changing. So the atomic mass has a unit of AMU, but the molar mass, the mass of 1 mole, has the same number, with the unit grams per mole. So that's the thing. So it becomes easy. So you can take any element. The molar mass of that element is going to be what? The atomic mass in grams per mole. So it's pretty easy. The things become easy now. Okay, I want you to be sure about that. So if you're thinking about a mole, the mass of 1 mole of atoms, it is atomic mass in grams. You have to say the atomic mass in grams, and it's also called what? Molar mass, because it contains Avogadro number of atoms in that. So 1 mole of helium is 4 grams approximately, because if you look at the periodic table, the atomic mass of helium is given as 4 approximately. And then that always contains the Avogadro number 6.022 10 to the power 23 atoms of helium. Okay, now this can be extrapolated to molecules also. Instead of atoms, you can take molecules. For example, if you're taking water, we got H2O molecules. And when you say 1 mole of water, that will have the same number. That is the Avogadro number of molecules. And if you take sodium chloride, we have 6.022 10 to the power 23 formula units of NaCl. Now, for a metal, non-metal compound, which is usually called as an ionic compound, we don't have a separate, molecule. Sodium ions and chloride ions are arranged in a 1:1 ratio. That's why we call as formula units there. Technically, you have to say formula units, but in future we won't be saying that, for simplicity. So many formula units of sodium chloride is present in 1 mole of sodium chloride. Okay, now molar mass of water. How will you find it out? Instead of taking the atomic mass for an atom, here you have to take the molecular mass of the compound. For water, 2 hydrogen is 2 and 1 oxygen is 16. Add the 2 and 16, you get 80, which is the molecular mass. And you say it in what? Grams per mole. That becomes the molar mass of water. If you take the molar mass of sodium chloride, you take the atomic mass of sodium, which is 23, chlorine 35.5, add them together, you get them, the molar mass, in grams per mole, 58.5. So this is a simple thing. I think you got the idea. So we have 2 things here. Every mole, whether it be atoms or molecules, contains the same number, which is the Avogadro number. And the second thing is actually the mass, the molar mass, which is, if it is atoms, you say atomic mass in grams per mole. If it's molecules, you say what? The molecular mass in grams per mole. So that's the idea. So it's just like a coin. A coin has 2 faces. Just like that, mole has 2 things associated with that. Mole has the number of atoms or molecules, depending upon whatever you are taking. And then moles have the mass of the element of the compound or molecules, the mass. So you got a number and the mass. Okay, and we know that mole and number are connected by what? The Avogadro number in all cases. That doesn't change. The number doesn't change. While mole and mass is connected by the molar mass. This is one important thing you must remember. Always you remember the mole and the mass is connected by molar mass. Okay, so usually I tell the students, just remember it, because sometimes when you come to an exam, you may forget how to connect the grams of the substance with the moles of the substance. So I just tell the students, just remember it by just rhyming moles and mass, molar mass, mass and molar mass. Or if you want, when you take brushing your teeth, you can say mass, mole, molar mass, mole, mass, molar mass. Go on like that. You just will be remembering that. So don't forget this idea. So mass and mole is connected by molar mass, while mole and the number is connected by what? The Avogadro number. This is the basic thing. All calculations are based upon that. Let's do a particular calculation here. How many moles are in 3.01 10 to the power 22 atoms of neon? Okay, what is given here? We are given the number of atoms. What do you want? Question asks you how many moles. So what is the connection? We had to connect the number with the mole. A number and mole is always connected by what? The Avogadro number. So connection is 1 mole is the Avogadro number of atoms. We can use it in a calculation. So the calculation will be like this: 3.01 10 to the power 22, which is a given thing. Keep the mole on the top. Then, if you use the Avogadro number, you're going to get what? A 0.0500 mole. That is your answer. It's pretty easy. You can do it like that. Okay, let's take another one. Calculate the mass of 2.50 moles of calcium. So what is given here? You're given the mole. What do you want? You want the mass. So here comes your, brushing your teeth thing. Mass and mole, molar mass. So how will you get the molar mass of calcium? Very easy. Take your periodic table. Find the calcium in the periodic table. The atomic mass you take out and say in what? Gram per mole. So it's pretty easy. So the calcium you can find out is, 40 is the number given in the periodic table. So I know. So your given is 2.50 moles of calcium, and you have to find the mass of that. And the data from the periodic table we have found out molar mass of calcium is 40 grams per mole. Now the thing is easy now. Just start with the 2.50 mole. Since we want the gram, keep the gram on the top. So the calculation is pretty simple. 2.50, 40 over 1 mole. If you calculate, you get 100 grams of calcium. It's pretty easy. You can do that. Now, I just have this. See, always I say that, tell the students, keep it in your mind. You write it for so many times. You say it so many times. You always remember mole and mass is connected by molar mass. Don't forget that. Now comes here a compound, carbon dioxide. Find the mass of 3.50 moles of carbon dioxide, a compound. So, given is the moles, what you want is what? The mass. So, mole to mass, molar mass. You already know that. Okay, so we have to find the molar mass of carbon dioxide. How will you find out? We know that we have to add up the atomic mass of carbon and the atomic mass of 2 oxygens together. So, carbon 12, 16 times 2, you're going to get what? 12 plus, 32, which is going to be 44 grams per mole. Now, we use that molar mass and start with the 3.50. Since we want the gram, keep the gram on the top. Pretty simple. You calculate it and you get what? 154 grams. Pretty easy. I know you got the idea. This is the whole thing about the mole constants. Nothing more than that. Okay, let's go to the next one. Question is, how many atoms? Again, you have to find the atoms in 12.5 grams of potassium. Now, this is not a straightforward thing. What is given is the mass. Okay? And what you find, you have to find out the atoms. So, it's not straight. You have to go from the mass to the mole and mole to the number of atoms. That's the way you have to go. Okay? So, from mass to mole, because mass is given, mass to mole, what do you need? Molar mass. And the molar mass is the atomic mass in grams per mole, which is 39.1 grams per mole. And then mole to number of atoms, you have no problem. Always it's the Avogadro number. So, we have these two. Start from 12.5, do the calculation, 12.5, and we want the mole, keep the mole on the top. First step. Second step, we want the atoms, keep the atoms on the top. Don't stop at the first stage. Go calculate the whole thing. And you are going to get 193, 10 to the power of 23 atoms of potassium. So you can straight away go from gram, but you have to go to the mole first. From the mole, mass to the mole, mole to the number of atoms. Okay. Okay, now, it's sometimes pretty interesting. I got a bottle of water which contains about half liter, that is 500 milliliter of water in this one. So when I'm drinking this water, a half liter of water, 500 grams of water, how many water molecules I am just drinking or taking in? That's a pretty interesting thing to calculate. Okay, so let's go find out that. So find the number of molecules in a bottle of water which is 500 grams of water. So what is the idea? Given is the grams. Okay. What do you have to find? You have to find the number of molecules. Again, the idea is this. What is the idea? We have the molar mass which can convert the grams into the mole. Second is what? From the mole to the number of molecules, use the Avogadro number. So the calculation is what? 500 grams. You use the 18 grams per mole with the mole on the top, and then the number of molecules on the top for the Avogadro number, and that gives you 1.67 10 to the power 25 molecules of water. So it's pretty easy. You can actually do it for an atom or a molecule based upon that. Okay. Now, let's think about this. It's a questions given in your textbook. Let's think about this thing. Calculate the number of atoms in each of the following. Okay. First question: 52 moles of argon. Okay, we know it's pretty simple because you have to go from the moles to the number of atoms. It's pretty easy. Mole to atoms, Avogadro number. So we start from the mole. We use the Avogadro number with the atoms on the top. So you easily calculate the number of atoms. Just 3.13 10 to the power 25 is pretty easy. Now second is 52 U. What is U? AMU. Okay. So 52 AMU of helium. How many atoms are there? Okay. Now AMU, is on the level of atoms, and whatever is given on the periodic table for helium, the atomic mass given is in AMU. So always in the periodic table, you can say the atomic mass is given in that particular unit. So we know one atom of helium is 4 atomic mass units, or U. So we can use as a conversion factor. One atom of helium equivalent to 4U. If we just use it as a conversion factor, one atom comes on the top because we need the atoms. 4U comes at the bottom, and from the 52U, you're going to get what? 13 atoms. So pretty easy. You can easily do that. Third question is this. Calculate the number of atoms in 52 grams of helium. We already done this. You remember that? We are given the mass. And we have to calculate what? Number of atoms. You have to go from the mass to the mole to the number of atoms. So, given his mass, wanted his number of atoms, and our path is what? 52 grams of helium to moles. Using what? Mass to mole, molar mass. We know the molar mass. How will you get the molar mass? Use the periodic table. We already know it's 4, so it should be 13 grams per mole. Second step is mole to number of atoms. We use the Avogadro number. So if you calculate starting from the 52 grams of helium, use the molar mass to find the mole, then use the number of atoms, Avogadro number thing, and then you are going to get what? The number of atoms in that. Okay, another question. In 3 moles of ethane, C2H6, I have given a model of that here. See, the 2 central atoms are carbon, and the blue, red and the green colored atoms are hydrogen atoms. So 3 plus 3, 6 atoms of hydrogen. So that is the molecule here. So one molecule of ethane has 2 carbon atoms and 6 hydrogen atoms. Question is this. Find the number of moles of carbon atoms in the 3 moles of ethane. Number of moles of hydrogen atoms in the 3 moles of ethane, and then number of molecules of ethane in the 3 moles. So let's go one by one. We know this molecule, if you look at the molecule C2H6, if you look at that C2H6, one molecule has what? 2 carbon atoms and 6 hydrogen atoms. So if you take 3 molecules, we are not talking about the moles, let's take about the molecules first. If you take 3 molecules, then what? You have to multiply carbon atoms 2 with the 3, that gives you 6 carbon atoms. Hydrogen atoms 6 with 3 is going to be 18 hydrogen atoms. So 3 molecules of ethane contain 6 carbon atoms and 80 hydrogen atoms. Now, how can we go from here to the 3 moles? Remember, the molecules and the moles, the connection is Avogadro number. So if you multiply the 3 molecules with the Avogadro number, you're going to get what? 3 moles. So if you multiply this with Avogadro number, you have to multiply this also with Avogadro number and this also with Avogadro number. So basically, we can change the 3 molecules into 3 moles of ethane. 6 carbon atoms into 6 moles of carbon atoms. 18 hydrogen atoms into 18 moles of hydrogen atoms by multiplying throughout with the Avogadro number. So basically, we can say what? 3 moles of ethane contains 6 moles of carbon atoms and 18 moles of hydrogen atoms. That's the answer for the, your first question. So let's go to the second one. What's the number? Now, what's the number of? Third question, I think. So number of ethane molecules in 3 moles. Pretty simple. A mole is Avogadro number. So if you got 3, multiply with the 3. So 3 times Avogadro number is going to give you the number of molecules in the 3 moles. And you can just multiply that. And the multiplication gives you 18, 0, 6, 6, 10 to the power 23. And then if you want in the standard form, it's going to be 1.807. I just rounded it up to, that 23 number of, decimal points. 1.807, 10 to the power 24 molecules. Okay. Now, which one of the following will have the largest number of atoms? Okay. 1 gram of gold, Au. 1 gram of sodium, Na. 1 gram of lithium, then 1 gram of chlorine. So if you take 1 gram of each, how many atoms? We know that we can go from the mass to the mole to the number of atoms. Okay, but the moles and number of atoms are proportional. So it's only asking about a comparison. So what's the strategy? Okay, we can say that from the masses of the substance given, we can easily find where the moles using the molar masses of each of them. Now we can find the molar mass of all of these substances from the periodic table. The atomic mass expressed in grams per mole is going to be the molar masses. So you can use the molar masses, divide each 1 gram with the molar mass, molar mass, molar mass, molar mass. You're going to get what? The moles of each of them. Now, since the number of atoms are proportional to the moles, because moles to number of atoms, you just multiply with Avogadro number. That is the same for all of them. So they're proportional. So you can, since the number of atoms are proportional to the moles, the largest mole gives the largest number of atoms. That's the question. So if we look at all of these things, so the least, denominator is going to give you the largest number. The value will be greater when the denominator decreases. So the largest fraction in this case is that for lithium, which has got a 6.94, the least number, and that is a winner. That has got maximum moles, and that's got maximum number of, largest number of atoms. So even without calculating, you can say that is going to be what? The one with the largest number of atoms. So the last problem is this. We are talking about isotopes and natural abundance and the isotopic mass, which is the average isotopic mass. I just trying to see if you have actually gone with the last class and you are actually sure about the atomic mass idea. So the question is this: bromine has 2 natural isotopes, bromine 79 and bromine 81, and the atomic mass, that's the average atomic mass, is 79.904 AMU. The mass of bromine 81, one of the isotopes, is 80.9163 AMU. That's isotopic mass, and its natural abundance is 49.31%. Okay, calculate the mass, that is the isotopic mass, and the natural abundance of bromine 71, the next isotope. You have to find it out. So you have to find 2 things: the abundance as well as the isotopic mass for bromine 79. So what is the strategy? Okay, since there are only 2 natural isotopes here, the percentage of bromine 79 can be found by the difference. That means what? The total is always going to be percentage is going to be 100. So if you take the percentage of 81, bromine 81, 49.31 from 100, the rest is going to be your bromine 79. So we can find the isotopic mass by, the abundance by the difference. Then we can actually find the average. Okay, But only thing which is missing is what? The isotopic mass of the bromine 79. So we can just, say, you can assume the isotopic mass of bromine 79 is an X, and then calculate the average by using our idea. That's an algebraic way of calculating it. So let's go to the calculation thing. So these are the given things. The atomic mass is 79.904. Mass of bromine 81 is the isotopic mass of bromine 81 is 80.9163, and the abundance is 49.31%. Okay, what do you have to find out? You have to find out the isotopic mass of bromine 79 and its abundance. So what is the first thing you can do? You can do this very easily. The abundance, natural abundance of bromine 79 is going to be what? The 49.31 taken away from 100. So 100 minus 49.31, which is going to be 50.69%. So we have answered one of them. Now, what's the next thing? Let's do the algebraic way of, the average. So let us assume the mass of bromine 79 is X. Okay. Then calculating the average atomic mass. So how will you, find out the average atomic mass? You convert the percentage into fraction. Multiply each fraction with the isotopic mass. Add them together. That's the idea. Okay. So 80.9163, that is isotopic mass. And the 49.31 you divide with the 100, which is 4931. Multiply them together. Go to the next isotope, which is your bromine 79. So X, because we don't know that, multiply with the fraction which is 0.5069, and the total is going to be the average atomic mass 79.904. Now you know how to calculate it. You just find out this part of the equation, and that part is minus from the 79.904. What you get is what? X times 0.5069 is 40.004 by calculation, and X is going to what? 79.92. Okay, so the answer is the isotopic mass of bromine 79 is 78.9. So the answers are, you need two answers. The abundance of bromine 79 is 50.69, and the isotopic mass of bromine 79 is 78.92 or 92 atomic mass unit. So that's how we calculate it. I think you have actually, got the idea of the mole concept. I want you to be very sure, and so that you can be, a resource person for the other students. So be very sure about that. So if you are actually very happy about this, what we have discussed, just let me know your, comments, suggestions, or even a thumbs up. And also you can subscribe. Subscribing is good, because whenever I just upload a new class, you know automatically a new class is there. So just do that. Thank you.